facility track today. For those of you that are new to or have just come in, I mentioned earlier, we've recently sent out an email to the Rack and Power community group email requesting answers to a survey. The survey is actually just to get an idea of exactly what, with ORV3 development coming to an end right now, what you guys would be interested in us focusing on in the future, such as enterprise solutions in the V3 space. So we'd really appreciate it if you could take a couple minutes just to do that survey if you get a chance. But for now, I'm going to hand over to Richard Banyard, who's going to present the topic on Google's implementation of the Open V3 rack.
Hi guys. As Steve mentioned, my name's Rich Banyard. I'm a senior design engineer with Rittal, based in the UK. Today I'm going to be talking through the Google implementation of the Open Rack frame specification. In particular, there's kind of two types. You've got a shallow and a deep, or a version 1 and a version 2. I'm going to be focusing on the version 2, as version 1 was discussed in the summit last year. So in terms of envelope, the OCP, the rack, the standard specification doesn't actually define like an overall envelope. In the Google's implementation, in terms of similarities, the version 1, version 2, same width, same height. It's a 24-inch internal width rack, and 39.5 OU kind of internal usable space. The main difference between the two versions is clearly the depth. So version 2 is about 50% deeper. So you get a lot more kind of like bang for your buck, a lot more space inside the rack. And the envelopes defined in the specification also include all the accessories. So if you're bolting on doors or cable management, anything like that, that's all kind of included within that 706, 805, 2054, or 706, 1292, 2054. So in terms of the operating conditions, the Google implementation is similar to the OCP specifications. There's a few differences, but more or less some very similar ballpark. Where it starts getting a little bit different is Google implementation specifies altitude, like operational altitude and non-operational altitudes, and obviously the required airflow throughout the rack, which is measured. You got 125 cubic feet per 1 kilowatt of power deployed, where the OCP specification at the moment a lot more open and not nailed down so much. Perhaps one of the more obvious differences to the naked eye between the OCP specification and the Google specification is the position of the bus bar. You've got a left-hand bias, and that kind of allows a bit more equipment space, a bit more utilization of the space within the rack, within the data center. So the image there shows the two possible positions in the envelope depth number 2, which is a deep version. So the one towards the front, that marries up exactly with the envelope 1. So you can deploy kind of standard equipment, shallow equipment within this rack. And that allows you a lot more space at the rear of the rack for, again, data management, PDUs, cable ingress access, cooling units. And then, the deeper version is approximately 275 mil further back, but in the same width. Again, obviously that allows you to deploy much deeper equipment, so make it a more kind of like densely populated kind of server. In the width of the rack, it's measured from the left-hand side, obviously, and that position in both the shallow and the deep position tallies up with envelope depth 1. So, as I say, you can deploy shallow equipment in a deep rack. So there is a requirement for seismic mounting points for deployment in seismic zones. It's the same front and rear, so we've got 4 positions front, 4 positions rear, and it's an M8 kind of thread requirement. whether you do that through inserts or directly into the frame or however else. Yeah, the requirement is for the M8. And the additional to that is it could be used for shipping, like a shipping bolt down, or while the rack's in transit. So there's a requirement for accessory mounting positions. So this is front and rear. We've got about 26 mounting points at the rear of the frame. These are holes kind of positioned for or sized for M5 self-tapping screws or an M5 thread. And then beside that, you've got 8mm diameter clearance holes. And on the front, again, you've got 20 M5 positions and 10 8mm positions. So yeah, as I said, this is used for mounting accessories, again, doors, extensions, cable management. So the blue circled holes there are obviously the M5s, greens for the 8mm. It doesn't follow that pattern all the way up. I haven't worried about putting all the positions on this presentation. It's a bit dense. But that's the kind of configuration you get. Okay, so additional to front and rear, there's also opportunities on the canopy. So there's a requirement for M12 fixing positions in the canopy. So again, this can be used for seismic, fixing it to the structure of the building, or the data center, and also baying racks together. I mean, in this image, I've highlighted in green the M12 positions. Because you've got a deeper rack, you've also got the opportunity for more baying or bracing locations. So depending on the infrastructure, you can position these M12s wherever's kind of necessary. So we've got M5 thread forming positions again, either M5 thread forming or M5 kind of machine threads. And all this allows for is, mounting of canopy mounted accessories. So again, like switches, cable management, front to back. But with the internal height at 39.5 OU, anything you stick on top is likely to take it outside of the Google specification in terms of height. So yeah, just kind of bear that in mind. And again, so with a deeper rack, you've got more opportunity to kind of like utilize space within the rack. Obviously, cable management is always like a hot topic and is always kind of sought after. Every millimeter counts. So with this kind of 6-post design, it gives you a lot more room kind of between each of the posts to fit cable management and whatever other accessories. And yeah, as mentioned, if you're using shallow gear, you've got a lot more space at the rear for kind of PDUs, switch gear, and cooling equipment as well. So in terms of the equipment interfaces, there's only 3 interfaces that are kind of specified. So you've got an M4 machine thread, and then a set of rectangles, essentially 12 by 12.5, with the center line of those going up the M4s. And then 36.5mm further back from there is M6 machine thread. So the idea is for the squares, you can use it for toolless equipment engagement, and then obviously the fastening positions, we can more semi-permanently fix equipment into the racks. So further to the kind of vague testing requirements that are in the OCP requirement, the Google specification goes into it a lot more. So we've got vibration, accelerated life, transportation testing, so simulating air transit and kind of truck transit per the ASTM standard. Safe disembarking via ramp. 19mm drop off, so this is kind of testing the casters, making sure they're kind of capable of taking a fully populated rack off a drop, off a ramp. Center of gravity requirements, and then there's also a seismic loading requirement. So yeah, full seismic testing is kind of required on a physical product. So further, like sort of additional supplementary bits in the spec, leveling feet. So the idea is it has to be able to, the rack should be able to be redeployed. So if any equipment has become redundant, or if the rack itself needs to be moved, it can be kind of, yeah, reset to its casters, moved, and then redeployed. And the Google requirement is only to lift it 6 millimeters off the ground. I think the OCP specification is up to 15 millimeters, but yeah. There's a requirement for side panels, so this is for security reasons and air recirculation, keeping that as efficient as can be. And then casters, much like the ORV3 rack, there's 4 swivel casters, and yeah, they must kind of support the maximum loading in dynamic conditions, however the rack's going to be deployed. So in terms of call to action, I mean, like I say, this is kind of like a run through of the spec, so there's not really a lot of that you can call to action. However, we did have a Rittal version of it, the Rittal stand, and obviously you can join in through all the relevant wiki pages and get on the mailing list, look at the latest specification. And yeah, obviously the mailing list keep you up to date. So that's me. Any questions for anybody?